When there are nested for each commands, Genexus must first determine the base tables of each one of them. When the developer indicates the base transaction, it's done right away. Otherwise, Genexus has to determine each base table according to the attributes included in every for each command. This case is more complex and will not be addressed in this video. Next, Genexus defines the necessary navigation to solve the multiple query. One of three options will be applied: join, Cartesian product, or control break. As we've said, the first thing Genexus does when it finds a couple of nested for each commands is determine the base table of each one of them, in an ordered manner and from the outside in, starting from the outermost one. Only then it determines how navigation will take place. In every for each command, the indicated base transaction and only the attributes that belong to this for each command come into play, from the order, where, and so on, as well as those in its body, except for those included in a nested for each command. That is to say, removing the nested for each command, the base table is determined as in a simple for each command. The attributes of the when none clause are never taken into account. All attributes must belong to the extended table of the base table found, which matches the base table associated with the base transaction. The attributes that don't meet this condition will not be instantiable because they can't be reached. In this example, it's done in this order. 1. The base table of the external for each command is determined. To this end, the indicated base transaction is considered, that is to say, country.city, and it's checked whether the attributes included in the print block, country name and city name, belong to its extended table. Otherwise, a warning is displayed in the navigation list to inform the user that some attributes cannot be instantiated because they can't be reached from the extended table of that for each command. In this case, country name and city name belong to the extended table of country city, the base table of the for each command. Secondly, the base table of the nested for each command is determined. The attraction base transaction is considered, as well as the attraction name attribute included in the print block. If a base transaction hadn't been written, something related to the external for each command attributes would be considered to determine the base table of the internal for each command, but this is not the case. Thus, its base table is determined as if it was a standalone for each command. Therefore, its base table will be attraction. The three examples of nested for each commands that we've seen before are based on the determination of base tables. Now we'll examine them more closely. When the base tables are different, there are two possibilities: whether or not there's a direct or indirect one-to-n relationship between them. In the first case, for each record of the main for each, the nested for each will run its instructions only for the n associated records. The operation that cuts the data from a table by that of another one is known as a join. In the second case, when there is no relationship for each record considered in the main for each, the nested for each will run its instructions for all the records of the other table, because it has found no relationship between them. This operation is known as Cartesian product. When the base tables are the same, an operation known as control break is performed. It takes place when we need to group the data from a table, run certain instructions that consider the group's common data, and then run through each member, and then run other instructions to move on to the next group and repeat the process. In this case, we must indicate the attributes that make up the group using the order clause. This case occurs because the same base transaction was specified for the external for each command and for the nested one. If the base transactions of the for each commands have not been specified, as we said, Genexus will calculate them from the attributes it finds within those for each commands. But it will only infer that you want to implement a control break if the base tables found by it are the same. We won't go into details about it in this course. Let's look at this other case. Note that here, the second for each command would be unnecessary, because for every attraction selected at a given moment in the external for each command, there's only one related country-city record. So, this would be the same as not writing the second for each command and sending to print the country-city print block that contains country name and city name, which both belong to the attraction extended table. Let's examine these two cases of one-to-n relationship between the for each commands, and therefore of join. The first one is direct. Note that the base tables of the external and nested for each are country, city, and attraction, respectively. They are related by a one-to-n relationship. The name of the country and city will be printed, and for each pair, their attraction names. The second is indirect. The base tables of the external and nested for each are country and attraction. If we look closely, each country has n cities, each one with n attractions. The base tables of the for each commands do not have a direct one-to-n relationship, but they do have an indirect one, through the country-city table. In other words, note that the base table of the first for each country is included in the extended table of the base table of the nested for each attraction. Then a join will be made. Let's look at the navigation lists. For the nested for each, which in both cases navigates attraction, the entire table is not run through. Note that in the first case, where the relationship is direct, the @ sign indicates that it will be filtered by the composite foreign key that establishes the relationship, country ID and city ID. In the second case, we see that it will be only by country ID, which is part of the composite foreign key. Note that in both cases, instead of ordering the navigation by the primary key of attraction, which is attraction ID, it does so by the relation attribute or set of attributes. To do so, it has an index automatically created by foreign key. In this way, the database access will be optimized. Therefore, after determining that it will make a join, Genexus tries to optimize its navigation. Here's a third example. In this case, suppliers have been added that offer tourist attractions, and therefore, two more tables appear, supplier and its subordinate, supplier attraction. In addition, we have the airports, which belong to a country and city. Then if we look at the for each, we see that the base table of the external for each is supplier attraction, and the base table of the nested for each is airport. Let's assume for this example that the print block info shows the name of the supplier, the name of the attraction, and also the date on which that attraction will be shown, and the second print block shows the name of the airport. Note that there is an indirect one-to-n relationship. That is to say, for every supplier attraction record, there will only be one attraction record, given that we obtain only one from country city, which in turn is related to n records of airport. The n airports found in that country/city, even though in general there's actually only one. In this model, there may be several. Here Genexus finds attributes in common between the extended table of the main for each command and the base table of the nested for each command. Which ones? The pair, country ID, city ID, it'll make the join through them. For optimization reasons, we can see that it chooses the index by foreign key of the airport table. In short, this is a case where the relationship between the base tables is not directly one-to-n, but indirect, through intermediary tables. Let's see now this case of nested for each commands, with different and unrelated base tables. Here, the first for each navigates category, while the nested one navigates country city. In this case, there is no one-to-n relationship of any kind, contrary to what it might seem. Looking at the table diagram, we see that a category has n attractions, each of which has one and only one country city. One would think that for each category, the country city of each of its attractions would be listed. That would be true if the base table of the nested for each were attraction. But it's not. It's country city. So Genexus understands that we're not looking for the records related by attraction. If we were looking for those, it would be enough to specify attraction as the base transaction for the second for each. This can be a misleading case, so it's essential to read the navigation list carefully to avoid any confusion. In the listing, we can clearly see that no join is being made. In this case, Genexus can't find a direct or indirect one-to-n relationship between the tables. Therefore, it doesn't apply implicit filters to the nested for each records. That is to say, it makes a Cartesian product between the tables. For each base table record of the external for each category, it considers all records of the nested for each base table, country city. In this case, we want to list all countries. For each one of them, we want to list their cities, and for each city, we want to list their attractions. The only restriction is that we want to do it only for the countries and cities that have tourist attractions recorded. That is to say, we will have to implement a double control break, in which first we group by country, and within it, we'll then group by city. Within the latter group, we'll show the names of all attractions. To do so, we will define the grouping criteria using order clauses. Remember that the order is very important in a control break. It not only indicates the attribute or attributes used to list data, but also sets how to group it. We could indicate an order for the innermost for each, but this order will only be used in the conventional manner. That is, it will be used only for ordering purposes. We'll see this soon. We have a double control break, which implies 3 for each commands. If we look at the navigation list, we can see the word break for every internal for each, indicating the same base table, attraction, and therefore a control break. In addition, it'll run through this base table only once. To do so, it needs to order by the concatenation of the attributes included in the orders of the for each commands. That's why it chooses country name, city name. Note that in the second for each, the break is performed by country, iterating on the country it's positioned in the first for each. In the third for each, the break is performed by country and city, iterating on the city it's positioned in the second for each. Here we see an example of how it would be displayed if this were the data. First, we see the country, and for it, we see the first of its cities according to its name, and the tourist attractions of that country and city. Then we see the next city of the same country and its attractions. And only when there are no more cities of that country, the next one is shown in alphabetical order. And it starts all over again. Country, city, attractions. Think about how the previous list will be executed if instead of ordering the first for each by country name and the second by city name, we would have sorted both or just the first one by the pair country name, city name. Note that in this case, the navigation list will be different from the one shown above, in the second for each. There, Loop while will read country name equals at country name, and city name equals at city name. This means that at runtime, now the same information will be seen in this other way. That is, the country comes out, its first city, and its tourist attractions. Then the same country and its second city and its tourist attractions. And so on until the country changes and the same thing happens again for the next one. Clearly, the information is being presented differently just by having placed city name in the first or in the second for each. Now let's suppose that in the first example, in which the break is made by country and then by city, to then list the attractions, we add to the last for each, the innermost one, an order by attraction name. That is to say, we'll want the attractions of a country and city to be ordered by attraction name. The navigation list will change, and attraction name will be added to the order of the 3 for each commands, which leaves country name, city name, and attraction name. And if we run with this change, we see exactly what we were saying. The break is being made by country name, and that's why France comes out first, and Italy much later. Within France, the break is made by city name, and that's why Nice, which is alphabetically before Paris, comes out first. Within each of these subgroups, the attractions are ordered alphabetically. This is contrary to what happened in the first case, when we did not have the order by attraction name in the last for each. As we've seen, the break criteria are in navigation filters. Here we're giving these instructions. Order the run by the set country name, city name, attraction name, and execute the body of the first for each where only the country name is printed. And next, execute the second for each, which, as long as the country name does not change, must print the print block that contains only city name. But then immediately execute the internal for each, where, as long as the country name, city name pair does not change, it must print the attraction name. All that is to say, we can see that the filters remain exactly the same as when we didn't order the innermost for each by attraction name. So, as we said, this order that we've just entered is only useful for sorting and not for making a break. In a previous video, we analyzed a case study to determine how GeneXus applies filters when they're received as an attribute in the parm rule. Going back to that same case, we'll see how to prevent that filter from being applied. We then start from the design of transactions design that's displayed, and we needed to obtain a list showing, for a given client, and from a given date, all the tours he's booked, and for each of them, the contact phone numbers of the tour guide in charge. To achieve this, the source shown is proposed. Knowing that the base table of the external for each command is reservation trip, and that the base table of the internal for each command is tourist guide phones, does it establish implicit filters for the information it'll use? Yes, it'll show the phones of each tour guide. Why? Because GeneXus looks for a relationship between the extended table of the external for each command and the base table of the nested for each command. It's another way of looking for a one-to-n relationship, although in this case, it's an indirect one. If each reservation trip has a tourist guide ID, and in the table to be navigated, there's also a tourist guide ID, then GeneXus understands that due to the relationship between the information, it'll be the same. And that's why it'll make a join. It can be clearly seen in the navigation list, where the @ symbol always indicates context data. Note the @ customer ID, which refers to the value received in the customer ID attribute of the PARM rule. This @TouristGuideID refers to the value of the attribute with that name in the trip table accessed by the first for each command. If this is not what the programmer wants, is there a way to avoid these automatic filters? Yes, using a subroutine to encapsulate the code of this second for each command. If you do this, the navigation list will show it. Subroutines are blocks of code which are defined in an object by means of the subcommand, which can be called later within the same object and as many times as we want by means of the do command. In the next videos, we'll explain in detail how to implement them.